Welcome to Tough Dog's training program, where you're going to learn everything you need to know about suspension and how we at Tough Dog have designed our product to best suit the needs of four-wheel drivers right around the world. In this module, we'll be discussing the fundamentals of suspension. The suspension under any vehicle is designed with two key objectives in mind. The first is to support and control the weight of the vehicle and its payload, and the second is to insulate the occupants and cargo from harsh impacts from the road surface. The system is made up of a multitude of components, but the two most important are the spring and the shock. The spring's job is to carry the load of the vehicle and its cargo, and to keep the wheels forced downwards onto the road surface in the process. The spring is compressed by bumps in the road, and the energy is stored up and released back as the spring fights back. If we recall the basic laws of energy from high school science, energy cannot be created or destroyed, but only transferred. If the spring was left unchecked, the energy transferred from the impact with the bump would cause the spring to bounce up and down repeatedly, which would not be particularly comfortable for the occupants and not particularly safe either. Enter the shock absorber. Now, its sole job in life is to control the movement of the spring by transferring the spring's energy into heat through friction by the resistance caused. There is an inevitable trade-off between a comfortable ride and the suspension performance, which is compounded by the suspension designs that cover a range of different applications. Throughout the training, we'll touch on ways Tough Dog suspension minimises this compromise so that drivers can get the best of both worlds. In their most basic form, a shock absorber is a device used to control compression and rebound movement of your vehicle's springs in response to movement over uneven terrain while driving. A shock absorber works to absorb the impact of undulations in the road surface and to smooth out the ride for the passengers of the vehicle. Part of this working to maintain contact between the vehicle's tyres and the road surface at all times, which ensures the safest control and braking response from your vehicle. Tough Dog has a range of shock absorbers that come in a number of different styles, including nitrogen gas, foam cell and adjustable shocks. Each of these products are designed to suit different applications, and knowing which one to select is important to ensure the best performance from the vehicle and the best ride for the occupants. We'll cover the specific features of the shock absorbers in our next video, Shock Absorber Types. A shock absorber can come in many different sizes. Two common terms you'll hear are bore size and stroke length. Bore size in a shock absorber is the diameter of the piston or the inside of the pressure tube. The larger the bore size, the more oil capacity. The greater the cooling capacity through volume and a greater surface area to dissipate the heat generated. Stroke length is simply the distance between compressed and extended length of the shock absorber. Tough Dog's research and development team established the best possible shock length for maximum suspension travel and ride performance. Tough Dog shocks are matched in both length and valving to provide the optimum performance when matched with Tough Dog springs. When talking about the behaviour of the shock absorber, there are a few key terms you'll need to be familiar with. The compression stroke of a shock absorber occurs as the piston moves downward, pushing down on the hydraulic fluid, forcing it to pass through the piston valve assembly. This valve is how we control the rate of compression by allowing more or less flow. In practical terms, the compression stroke happens as the wheel travels upward. The rebound stroke is the opposite of the compression stroke. As the piston is pulled out, it moves upward through the shock body and the oil flows through the foot valve at the base of the shock as well as through the piston valve. The resistance, which we call rebound damping, to this oil flow from the valve sets is what allows the shock absorber to slow down and control the spring's energy. In practice, this is when the wheel is moving back downward. While the spring and shock both have a role to play in both up and down travel, it is the spring doing most of the work on up travel, compression stroke, and the shock really comes into its own during rebound travel, when it is called upon to control the energy generated in the spring. Valving refers to the strength of the resistance that the piston valve set and the foot valve set exert on the flow of the oil. When we discuss valving, it is always in conjunction with the speed of the shock's movement. High-speed movement is when the shock reacts quickly to a bump or impact and generally results in higher valving or higher resistance, which controls and dissipates the energy faster.